Hey everybody, welcome to Chapter 4, Section 3. In this video, I'm going to go over how to convert a quadratic equation that is in standard form into vertex form by completing the square. And all my examples, the a value, the coefficient in front of the x squared, is going to be 1. So at the top of the notes here, I have the standard form of the quadratic equation, which is, just ax squared plus bx plus c. And then I have the vertex form, which is what we're going to convert it into. And so it'll be a, but that in this video, that's just going to be a 1 there, or we won't have a number in front. So your equation will be x minus h squared plus k. And those h and k values, those are going to be combined to make the vertex, to identify it, right? So completing the square is a relatively simple process, and you're essentially going to do this. I just wrote it down just so you have something to reference. So move c over and add b over 2 squared to both sides. That doesn't really mean much to you right now, but once I do a few examples, you'll get what I mean. So here's our standard form equation, and a is 1, right? I mean, the title of the notes, a was 1. But if there's not a number in front of x squared, then a is 1. And so b is by the x, so b is negative 12. And then c is the constant that has no letters by it. So c is 18 currently. The reason why I say currently is we're going to move it over to the other side. So what I mean by moving it over to the other side is if it's a plus 18, you're going to have to minus it to the other side. And so we're going to have f of x minus 18 on the left-hand side of the equal sign. So you can leave that f of x there. If you just write negative 18, it's fine. But I like to leave it there because the answer is going to be a function. And so a function has to have f of x equals. And as a teacher, when I grade papers and whatnot, so many kids forget to write the f of x. So I just leave it there for the whole process. So I'm going to write f of x minus 18, and I'll leave a little space there, and I'll tell you why in a moment. And then I'm going to write the equal sign, and then I'll write x squared minus 12x. So that's where we are currently. Now what we're going to do is something called completing the square. So you're going to take that b term, which is the term that's by the x, so that's going to be the negative 12, and you're going to take that and you're going to divide it by 2 and square it. So that's what I meant right here when I said the add b over 2 squared to both sides. So here you can see that I've added in the b over 2 squared to both sides. The reason why we have to add it into both sides is because the rules of algebra dictate what you do to one side you must do to the other. Just like in the previous step, I minus 18 on the right hand side of the equal sign, and then I minus 18 on the left hand side of the equal sign. So if I'm gonna like magically enter in a new number, then the only way it's mathematically justified is if you do it to both sides. All right, so if I put a plus negative 12 over 2 squared on one side, I got to do a plus negative 12 over 2 squared on the other side, okay? And so if you need to use the calculator for this value right here, make sure you always use parentheses because this value needs to always be positive. It should always be a plus sign right here. So like negative 12 divided by 2 is negative 6, and negative 6 squared is positive 36. You'll get positive 36 as long as you type it in parentheses. You get a negative 36 if you didn't type in parentheses. So once you turn the negative 12 over 2 squared into 36, your problem is going to look like this. Okay, so the reason why this process is called completing the square is because we've just created a perfect square trinomial. All right, and so let me show you what that means when we factor it. So the left-hand side right now, we can just combine those, negative 18 plus 36. That's going to be a positive 18. So I'll write down f of x plus 18 equals. And then what I need to do now is I need to factor this. And if it's a perfect square trinomial, then it's very easy to factor. So what you're probably used to doing when you're factoring polynomials is you're used to looking at that last number and then looking at the middle number, and you're trying to think of what are the factors of 36 that add up to negative 12. And that's going to be negative 6 and negative 6, because negative 6 plus negative 6 is negative 12, and negative 6 times negative 6 is positive 36. So I then write x minus 6 times x minus 6, because that would be x minus 12x plus 36 in factored form. But of course, if you have the same binomial repeating itself, like x minus 6 times x minus 6, you don't have to write that. You can just write x minus 6 squared, because anything times itself is squaring, right? So that's what it means to be a perfect square trinomial, because when you factor it, it's just going to be like one binomial being squared, okay? And you don't really have to do all this to factor a perfect square trinomial. The shortcut I like to think of is, I like to think of it two ways. What's the square root of that last number? The square root of 36 is plus or minus 6, right? In earlier videos, we went over that all square roots have a positive or negative solution. And then whether you know to use a positive 6 or a negative 6 depends on the sign in the middle right there. Okay? So that's one way of doing it. So I'm going to use minus 6, so I just write x minus 6 squared, and then I'd have it factored. Another way of doing it is just looking at the b over 2 number before you square it. Negative 12, you have to carry the sign with it. It was a negative 12. Don't just write 12. Negative 12 over 2 is negative 6. So that b number is always going to be this number right here. So however you want to think about it is how I want you to do it. Okay, so if those two little shortcut methods don't work, like the square root, whether you use plus or minus, depends on this middle one, or just looking at this number, if that doesn't work for you, then you're going to have to do this every single time. So start getting in the habit of just looking at this number or thinking about the square root of that last number. So what I'm going to do to finish the problem is just bring down the f of x plus 18 equals, and then all you have to do is minus it over now. So minus 18 to both sides, and then it's just going to get tacked on the end there. And so it's going to say f of x equals x minus 6 squared minus 18. And now that is in vertex form. And so the nice thing about vertex form is you can identify the vertex from the equation. Remember, the vertex is at h comma k, and since vertex form has a negative h in it, you can think of flipping the sign that's on the inside number, but the outside number, keep the sign exactly the same. So instead of writing down a negative 6, I'm going to write down a positive 6, and then I'll copy the exact number that's on the outside, so negative 18. And so, yeah, there we go. I can easily identify the vertex. I've converted it into vertex form using completing the square. So of course, the way you can always check your work is by using the graphing calculator. So what I did was I typed in the original equation into Desmos, and then I typed in my vertex form equation into Desmos, and they make an overlapping graph. And then if I ask you any follow-up questions like where's the vertex or the x-intercepts or something, they're going to have the same x-intercepts or the same vertex because they're overlapping, right? So you can just tap on those to get that information. But here you can see that the vertex 6, negative 18 is exactly what I got. So I highly recommend you always graph these to check your work, especially if you're doing a multiple choice test, because the multiple choice answer that will work is the answer choice that overlaps with the original equation. So if your teacher ever gives you a multiple choice test and just says convert this function into that, you just got to graph it and see which two graphs match. Okay, so I'm going to do these next examples a little bit quicker. I'm going to start off by adding or subtracting that c term to the other side. So that means I'm going to minus 4 to both sides. And then when I rewrite the equation, I want to leave a little space here before writing the equal sign, because now I have to add in the b over 2 squared to both sides. So your b value here is 6. It's a positive 6. So what I'm going to do is I'm just going to write plus 6 over 2 squared, and then do that. Make sure you do that to both sides. If you don't do it to both sides, then you're going to get the rest of the parts wrong. So 6 divided by 2 is 3, and 3 squared is 9. So we're going to have f of x minus 4 plus 9 equals x squared plus 6x plus 9. And then we have to convert that perfect square trinomial into factored form. So that means you can think of it like this. What's the square root of 9? Plus or minus 3? Am I going to use plus 3 or minus 3? Look at this middle sign here. That's a positive, so I'm going to use plus 3. Remember, the easier way to do it is to just think, what's 6 divided by 2? 6 divided by 2 is 3. So, and it's a positive 3, so you're going to write x plus 3 squared. You can only use these kind of shortcut methods that I'm talking about here if it's a perfect square trinomial. If you do not know if it's a perfect square trinomial or not, well, if you're doing completing the square, it's going to be a perfect square trinomial as long as you do it correctly. But let's just say you're factoring a random problem and you're not sure if it's a perfect square trinomial, then don't do this method here where you take the square root of the number. What you want to do is just think, what are the factors of the last number that add up to the middle number? The factors of 9 that add up to 6 are 3 and 3. So I can write down x plus 3 squared because it's 3 and 3. So the left-hand side turns into f of x plus 5 because negative 4 plus 9 equals 5. And then what you'll want to do is minus that 5 to the other side, and then you will have converted it into vertex form. So my official final answer is f of x equals x plus 3 squared minus 5, and that vertex is going to be at negative 3 comma negative 5. Again, I want to encourage you to check your work by graphing it. Remember, the vertex form should always overlap with the standard form, and if you're unsure about the vertex, just tap on it. Okay, for this example, I'm going to start off by adding 6 to the other side. And then I'm going to complete the square by looking at that b value. It's negative 2. And then I'm going to divide that by 2 and square it and add it in to both sides. So that's going to make f of x plus 6 plus 1, because negative 2 divided by 2 is negative 1. Squaring that turns it into positive 1. And then the right-hand side will be x squared minus 2x plus 1. So I'm going to turn this into factored form now. And so since negative 2 divided by 2 is negative 1, I'm going to write x minus 1 squared. And then that's going to equal f of x plus 7, because that's what 6 plus 1 is. And then all we have to do is minus the 7 over to the other side. And once we've done that, we have it in vertex form. And then if I ask you to identify the vertex, just flip the sign on the inside, keep the sign the same on the outside, and there you go. And remember to check your work by graphing. They should overlap completely. So for this last example, you may notice that the middle term is odd. In the previous 3 examples, the middle term was an even number, so it divided by 2 very evenly. So if you have an odd number in the middle, the process isn't going to change at all. You're just going to have a weird looking final answer. So I'll start it off the same way I have the others. I had a minus 11 for my c term, so I'm going to plus it to the other side. And so I'll write f of x plus 11, leave a space, equals x squared plus 7x, and then have some space here. So we're going to add in our b over 2 squared term. So b over 2 is going to be 7 over 2 squared. And 7 over 2 squared is, 7 over 2 is 3.5, and 3.5 squared is 12.25. So I've always noticed that kids have a harder time doing problems like this when it has decimals in there, but you're going to factor it the same way you've done before. You can use those shortcut methods. If you take the square root of 12.25, it will tell you it's 3.5. Would you use plus 3.5 or minus 3.5? Well, it's a positive 7 there, so you're going to do plus 3.5. Also, it's even quicker if you just look at this number here. It's a positive 7 over 2, so that's going to be a positive 3.5. So this perfect square trinomial is going to factor to become x plus 3.5 squared. Then I just got to combine my two terms on the left-hand side. 11 plus 12.25 is 23.25. And now I just got to minus it to the other side, and I'll have it converted into vertex form. And then remember, when identifying the vertex from vertex form, flip the sign on the inside, so I'll have negative 3.5 for my x coordinate. Keep the sign the same on the outside, so I'll have negative 23.25 on the outside. And like the other ones, the graphs will still completely overlap, and you can always double check your vertex by tapping on it. So that's going to draw these notes to a close. Thank you for watching. Hope you learned something, and goodbye.